Welcome back. In this video, we're going to be talking about the formula when we are trying to find a z-score in a sample. And as you'll notice by the formula on the right, it's really not very different than the formula for population. We just have the different notation. The M means that the mean is of a sample, and the S means that it's the standard deviation where we have n minus 1 in the denominator. So the math is very, very similar. Just know that when you're talking about a mean, you're talking about a mean of a sample. When you're talking about standard deviation, we found the standard deviation by using n minus 1 in the formula. So we're going to practice a little bit with some critical thinking. And I'm going to read a scenario for you, and then we're going to work these problems out and locate these people in a z-score distribution. So at a big company, the average salary is $80,000 a year with a standard deviation of 5,000. So one standard deviation above is going to be 85,000. Two standard deviations above is 90,000. You get the picture. So Miguel earns $87,500 per year, Natalia earns $75,000, and Layla's salary is $2,500, not thousand, below the mean. So an actual X score of the salary is not given. We can figure this out. We're going to place these three employees in order from highest to lowest salary. So let's do that right now. So our initial quest is to find a z-score for each of these people in terms of their salary when compared to the mean. So Miguel has a salary of $87,500. I have the formula for a z-score here. We're going back to using the population numbers. Don't worry about that. And then we have a mean of 80,000 and a standard deviation of 5,000. So I'm going to just plug this in. I don't know the z, and that's what I need to know. So for Miguel, the z is going to be equal to his salary, $87,500, minus the total mean of 80,000 divided by 5,000. And I know that 87,500 minus 80,000 is 7,500. And if I take 5,000 and divide it into 7,500, Miguel's z-score is going to be a positive 1.50. So I'll put that right there. Miguel is 1.5 standard deviations above the mean. That makes sense because one standard deviation is 5,000, and add another half to that, 2,500 gives you 7,500. So 1.5 is Miguel's score. Let's take a look at Natalia's score next. Natalia's score is going to be z equals 75,000 minus the mean of 80,000 divided by 5,000. So 75,000 minus 80,000 gives us a negative 5,000. So 5,000 goes into negative 5,000 negative 1 times. So Natalia is 1 standard deviation below the mean. I know it's below the mean because it's negative. So that's Natalia's z-score is going to be a negative 1.00. I'll put that there. Layla's is a little bit trickier. We know that Layla's is 25,000 below the mean. So I know that 25,000 is the deviation from the mean. It's how much Layla is below the mean. So this actually equals a deviation score. This is how much Layla deviates from the mean. So for her, I can just use this as the numerator, negative 2,500, because her score minus the mean would be a negative 2,500. She's 2,500 below the mean. And then the actual standard deviation is 5,000. So 5,000 goes into negative 2,500. Negative, I'm going to put it right over here, negative 0.50. So in other words, Layla is a half of a standard deviation below the mean. So let's take a look and see where these folks would be in the normal distribution. So we have a z-score distribution drawn out here. You'll notice a couple different things. It has a mean of 0, And the standard deviations are labeled as such: +1 standard deviation, +2 standard deviations, -1 standard deviation, and -2 standard deviations. And this is our normal bell curve. So Miguel has a score of positive 1.50. So what I'm going to do is I'm going to come over here to +1 and +2. I'm going to draw a line sort of right down the middle, and that's going to be where Miguel is in the distribution. Next we have Natalia, who had a -1. So I'm going to look right over here. She's right on that -1. I don't even need to draw a line. I'm just going to go down, and I'll put Natalia here. And finally, we have Layla, who's at a -0.5. So that's halfway between 0 and -1. So I'm going to draw a line here, and that's going to be where Layla is. All right, let's take a look at these, how they stacked up. Miguel is obviously higher in the distribution, has the higher salary, followed by Layla and then Natalia. This is how they compare to one another in terms of their salary. And here's just a reminder of how they stacked up in order, with a z-score of 1.50 being highest, -0.5 being next, and -1 being the lowest. I hope this helps you to kind of visualize z-scores and how they can be graphically represented on a distribution. So in the next video, we're going to be we're kind of leaving the individual score piece, and we're talking about standardizing a whole distribution.